All right. If you would, guys, please turn to your books to page 809, technically 810, because we're going to get started in section 13.3. So we are on page 810 again. All right. In the previous section, we learned about Joel and Harim, and they were playing a game with two six-sided number cubes. The number cubes were rolled, and the sum of the two numbers, so sum, remember we added those two numbers together, the sum of the two numbers were calculated. If the sum was even, Joel won a point, so even for Joel, and if the sum was odd, Harim had 1 point. The experimental probability was then calculated, where we found the number of times the event occurs, the number of times we rolled a sum of 2 or rolled a sum of 6 was placed over the number of times that we performed the actual experiment. When calculating the actual probability of an event before performing the experiment, you are determining the theoretical probability. Theoretical probability is the mathematical calculation that an event will happen in theory. So this is in theory, okay, where we want our outcome over our total, okay, our want over our total, all right. Number 1, it was asking us to list our sample space again, okay. And if you guys can remember all the way back to the very beginning, to the first one, oops, sorry, I got some weird dice in here. The lowest number I could roll on my number cube was 1 out of 1, which gave me a sum of 2. And the highest number that I could roll on my number cube was 6 out of 6, which my sum of 6 and 6 is 12. But I could have every number in between. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 12. Okay. Below here, okay, it was asking us in the previous experiment, we found each outcome as the sample space is not as likely. Okay, I have 6 odds or 6 evens, and then I have 5 odds. Okay, one method to determine the probabilities of the outcome is to list all the possibilities, meaning if I roll my number cubes, what are all the possible combinations I could come up with when rolling a number cube? Okay, that's what we did in the last unit or in the last section. Or you could sit here and do this way. You can do it 5 and 4, which we already have down here is a 5 and a 4 for my first dice, or 4 and a 5 for my first and my second dice. Okay. When listing all the possibilities, all the possible outcomes I could have, how many total do I have? Well, I see that I have, if I roll a 1 for my first dice, I have 6 chances or 6 different opportunities or 6 different outcomes for the second one. So I have 6 rows here, and then I have 6 columns here, or 6 columns here and 6 rows here. Well, I have a total of 36 possible outcomes. Okay, I have a total of 36 possible outcomes. With these, I can create what we like to call a number array. Okay, a number array is almost looks very similar to our multiplication chart, okay, where I fill in all the information. Well, number 3 is saying I have the array shown, and it's already filled in number 2 and number 7 for me. And I want to know, what does the 2 and 7 mean to me in words? Well, the 2, well, it looks like it's 1 and 1, which is 2. Well, 3 and 4, which is 7. Well, that tells me, let me get that bigger. That tells me, well, I'm adding these 2. So in my number array, 2 and 7 mean the sum of my 2 numbers when rolled. Okay, it is my 2 numbers when rolled, the sum of both of my numbers. Okay, if you would please take a moment. If you don't know how to fill in the array, all you're doing is 2, and then this is 1. So 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Well, 5 plus 1 is 6, and 6 plus 1 is 7. Please take a moment, pause the video, and I would love for you to fill in the rest of this array and then come back with us. So that's 4, 5, 6, 7, 8, 5, 6, 7, 8, 6, 7, 8, 9. Oh, sorry. 8, 9, 10, 8, 9, 10, 11, 9, 10, 11, and 12. Okay, well, looking at my number array here, it looks like I have 6 numbers going down in each row, and then I have 6 numbers in each column. Well, 6 times 6 is still going to be 36 possibilities. When looking at both my number array here and looking at all of my combinations, all of my possibilities, I have 36 for either one. Does it appear that the list of possibilities when rolling a 2 6-sided dice cubes has the same number of possibilities as my number array? And the answer is yes. Same number of possibilities. Okay, I still have the same number of possibilities. All right. It might be easier for you guys if you guys would like to go back a little bit and pause on the number array, because what I want to do is I want to find how many times did I land on the sum of 1, or I'll put this right here. There we go. How many times did I land on the sum of 2? Well, it looks like I had the sum of 2 one time. Well, the sum of 3, I noticed that it's 2 times. Sum of 4 was 3. Sum of 5 was 4. Sum of 6 was 5. Sum of 7 is 6, not 7, 6. Then 5, 4, 3, 2, and 1. Okay. All right. I am asked to calculate the theoretical probability for each sum. Before I can do this, I need to find out, well, I have a total of 36. Okay. I need to make sure that I write that in. So then when I find the probability, I already have this. Well, what was the probability that my sum is going to be 2? Well, it's 1 out of 36 total choices. Okay. Probability that my sum is 3. Well, it's 2 out of 36 total choices. And I see that 2 and 36 are both even. So 2 can go into both to get 1 out of 18. The sum of 4, it happens 3 out of 36 times, which 3 and 36 can reduce by 3 to give me 1/12. 5 happens 4 out of 36 times. Well, this can be reduced to 1/9. The sum of 6 is 5 out of 36. Well, 1 is odd, 1 is even. That cannot simplify. The sum of 7 happens 6 out of 36 times, which is 1/6 the time. The sum of 8 is 5 out of 36. The sum of 9 is 4 out of 36, which is 1 out of 9.
Teachers and students,
the sum of 10 is 3 out of 36, which can simplify down to 1/12.
Again, 8th graders should be heading to their
sum
seventh
of
period
11
class.
is 2
in class
out of
until we make our
36,
next announcement.
which can reduce down to 1 out of 18. And then the sum of 12 is 1 out of 36. Okay, 1 out of 36. All right. Is there an equal likely chance for each number to result when rolling this number cube here? So looking at our array and adding everything out, do I have the same chance of landing a sum of 12 as I do a sum of 10? And the answer is no. Okay, the answer should be no. Well, let's think about this now. Because when we did the experiment in our last section, we saw that Joel was going to win. Because what we did is we looked right here. We looked at all of those sums here. Okay? And we saw that there was one more even than there was odd. Well, let's take a look at this one. According to the theoretical probability, so in theory, who should win the game? So remember, Joel is even, and then Harim is odd. Okay? So I'm going to add up all the possibilities for Joel, which I'm going to take all of these numbers here and add all of those numbers up in the first column for Joel and add up all these numbers in the second column for Harim. So 1 plus 3 plus 5 plus 5 plus 3 plus 1, which I get 4, 10, and 4, which is 18. And then for Harim, it's 2 plus 4 plus 6 plus 4 plus 2, which that is 6, 10, and 2. Well, 10 plus 6 is 16 plus 2 is 18. What do you notice? There is going to be a tie. Good job. There is going to be a tie. All right. So looking at number 11 now that we know that it's going to be a tie, I want to see, did the experimental probability of your experiment in the previous lesson match the theoretical probability of my game? So on 13.2, okay, you guys probably need to look back in your section. 13.2, I said that Joel was going to win, okay? But based in our theory, it says that it's a tie. So did it match their answer? Sorry, I had to reread it. Did it match? No. And it says, why do you think the results of the experiment and theoretical probability were different? And this is because here, when performing an experiment, okay, I'm going to abbreviate here, each outcome varies, so not all outcomes will be the same. Okay, and you guys can also see that too. If you played the game on your own and not just copied down, you will notice that your numbers will be much different than mine. And that's because we're both playing the same game, but we have different outcomes. All right, so moving on. Number 12, it says calculate the probability that when rolling two six-sided cubes using your number array and explain your calculation. So you guys can flip back over and I'm going to have mine right here. All right, letter A, probability that the same number shows on each number cube. Meaning, I'm going to back out here some. Meaning, I want to know what's the probability that I'm going to have a 1 and a 1, or a 2 and a 2, or 3 and a 3, 4 and 4, 5 and 5, or 6 and 6. What is the probability that I'm going to have this? Well, in my number array, there are 36 possibilities. Okay? There are 36 chances. You can look at this or you can look at this one. They're both the same, just in two different ways. And I see that 1 out of 1 only appears one time. So each of these appears 6 total times. And 6 out of 36 can reduce down to 1/6. Okay? All right, what's the probability that the sum of the roll is a prime number? Okay, well, looking at prime numbers, so prime, that's all of my numbers that cannot go into one another. So it's going to be 1, 3, 5, 7, well, 8, 9, 10, 11, and 12. Okay, I want to make sure. Should double check myself. Let's see. Prime numbers, 2. Oh, well, I can't have a 1, but I can have a 2. Sorry, 2, 3, 5, 7, and 11. Okay. Well, I'm actually going to go back over here. Well, how many times can 2 show up? Well, 2 can show up 1 time. 3, let me back up here. 3 shows up how many times? 3 shows up 2 times. 5 shows up 4 times. 7 shows up 6 times. And 11 shows up 2 times. You're saying, well, why is it 9? Well, 3 can go into 9. So 3 times 3 is 9. Okay. So it's going to be all of those numbers added together over my total of 36. Well, 2 plus 1 is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which I should end with 15 over 36. Okay. 15 over 36. And this number right here can be reduced by 3. 15 divided by 3 is 5. And 36 divided by 3 is 12. Okay. All right. So sum that the roll is greater than 7. So all of my numbers greater than 7. I should have 8, 9, 10, 11, and 12. Those are all of my numbers greater. So 8, it shows up 5 times. I'm going to change the number color here. So 5 plus 4 plus 3 plus 2 plus 1 out of 36 total. Well, 5 and 4 is 9, 10, 11, 12, 13, 14, 15. Well, look, I already did that math. That's 5 over 12. Okay. And then the last question, it says, what's the probability the sum of the roll is 1? Well, we notice in our array that we cannot get the sum of 1. So that is simply 0 out of 36. Okay, number 13, it says, if the cubes are tossed 180 times, how many times do you predict the following sums would occur? So I am going to look back on this page right here, and I'm using these probabilities here. This right here is going to help me. So look, the probability my sum is 1. Well, I don't have anything, so it's going to be 0 over 36 is equal to, remember, it's my outcome over my total. Well, now, instead of rolling it 36 times, I'm going to roll it 180. And I'm going to go ahead and tell you, I'm going to be nice and tell you that that is times 5. Well, 0 times 5 is going to be 0. Okay. Now, the probability that I'm going to roll a 4 for my sum, or my sum's going to be 4, is 4 out of 36. Well, if I do this 180 times, it's still going to be times 5. Well, 5 times 4 is 20. And then the sum of 9, I roll 9, or the sum of 9 4 times. Well, it's going to be the same thing. I should, if I did this 180 times, I should get the sum of 9 20 times. Okay, I should get the sum of 9 20 times. All right, if you would, then go ahead and flip over to the very back. And what I want you to do is pause the video, fill out the letters D, E, and F, and then come back and check your work. So I'm going to have 3 out of 36 equals, I'm going to say X over 180 because that's unknown. That is still times 5. 1 out of 36 equals blank over 180. That is still times 5. And then my prime number, we simplified it, but I'm going to go back to out of 36 here because we've been dealing with 36 over 180, and that is still times 5 over here. Okay, times 5, and then times 5. Well, 3 times 5 is 15. So out of 180 times, I should get the sum of 10 15 times. I should get the sum of 12 5 times.
Pardon this interruption.
And then I'm going to have 15 times 5. So 5 times 5 is 25. 5 times 1 is 5, plus 2 more is 7. So I should land on the sum of a prime number 75 times total. Number 14.
Thank you.
Kelsey claims that getting a sum of 4 when rolling 2 number cubes should be 1 out of 11, since there are 11 possible outcomes. Do you agree with Kelsey's claim? If not, how would you convince Kelsey in what her thinking is? Let's not finish that off, but I'm just going to go ahead and tell you the answer is no, so that way we can just move on and not have to worry about really skipping it. Okay, problem number 2. A square spinner revisited. The square spinner shown is spun twice, and the results of the spin are multiplied together to produce a product that is recorded.
Please leave your bags in your 7th period class.
So, determine all the possibilities for obtaining the products using the list. Okay? Meaning, I'm going to take this spinner and I'm going to spin it 2 times. Well, let's just pretend that I spin 1 the first time. What are all of my possible outcomes that I could spin for the second time? Well, I can have a 1 and a 1, 1 and a 3, 1 and a 2, and 1 and a 6. Can I have any other things correlated with number 1 for the first time? No. So let's move on to 3. I'm going to spin a 3 and a 1, 3 and a 3, 3 and a 2, and then 3 and a 6. I can now spin 2 for the first one and have 2 and a 1, 2 and a 3, 2 and a 2, and then 2 and a 6. And then the last one is 6 and 1, 6 and 3, 6 and 2, and then 6 and 6. Okay, those are all of my total outcomes. Well, look, I have 4 rows and I have 4 columns. 4 times 4 is 16 total outcomes. Okay, 16 total outcomes. All right. Number 2, it wants me to list my entire sample space. Well, I'm going to skip this question because I would like to fill out my array first before I do that, so that way we can easily see what my outcomes are. Okay, well, spin 1, I could either spin 1, 2, 3, or a 6. And spin 2, I could spin a 1, 2, 3, or a 6. Okay. And what I'm doing here is I am multiplying my 2 numbers together. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 6 is 6, 1 times 2 is 2, 1 times 3 is 3, 1 times 6 is 6. All right, 2 and 2. 2 times 2 is 4, 2 times 3 is 6, and then 2 times 6 is 12. All right, now I'm on to the 3s. 3 times 3 is 9, and then 3 times 6 is 18. And then the last one is 6 times 6 of 36. Well, what are all of my possible sample space for my entire thing? And it's all of my products listed here. Okay, so my sample space is going to include 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, that is my entire sample space. All right. Now, are all of my outcomes equally likely? Meaning, do I have an equal chance of getting the product of 1 as I do the product of 2? And the answer is no. Okay, my answer is no. Well, let's calculate this. I have 4 by 4, which is 16. So 16 total. And I want to calculate the probability of getting the product of 1 is 1 out of 16. Probability of getting the product of 2 is 2 out of 16, or 1 out of 8. Probability of getting a 3 is 2 out of 16, which is also 1 out of 8. Probability of getting a 4 is 1 out of 16. Probability of getting a 6 is 4 out of 16, which is 1/4. Probability of getting a 9 is 1 out of 16. Probability of getting a 12 is 2 out of 16, which is 1/8. Probability of getting an 18 is 2 out of 16, which is 1/8. And then probability of getting a 36 is 1 out of 16. Okay. And the last question for number 6 on this page is asking me, did I calculate the theoretical probability or an experimental probability? Well, here we calculated the theoretical probability. Meaning, in theory, this should happen. We did not really spin the spinner. Should happen. Now, if we really truly spun the spinner, then our information would have been experimental. Okay, on to number 7. Calculate each probability shown for the square spinner. So what's the probability that's spinning? Okay, I'm going to show it back up here. So what's the probability that my spin results as an even product? Okay, so even, I need all of my 2's. Okay, so let's take a look here. So 2, I have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 36 is 12. So out of 16 total, I have 12 out of those are going to be even. Well, 12 and 16 can reduce by 4, which would be 3/4 should be an even product. Okay. What's the probability the spin results is an odd product? So 1, 2, 3, 4. I have 4 out of 16, which can be reduced by 4, which gets me 1/4 of that. These two, A and B, are complements of one another. Remember what complements means? They're opposite. So what's the opposite of an even product? That would be an odd. All right, letter C, it's asking, what is the probability the spin result is a multiple of 3? Well, let's think about it. My multiples of 3 are 3, 6. Now let me move it over here. So I've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So all of my possibilities that I could have, well, I've got 3, 6, 9, 12, 18, and 36. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 12 out of 16, which we just found the reduced form is 3 out of 4. Okay. And the second to last one, the spin results, that is a perfect square. Okay. Perfect squares meaning 1 times 1, 2 times 2, 3 times 3, 4 times 4. So like 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 6. 4 times 4 is 16. 5 times 5 is 25. That's what it means. So in this case, I have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 6 times 6 is 36. I have 4 perfect squares. So 4 out of 16 of my choices are perfect squares. So 1/4 of my choices are a perfect square. Okay. And then the very last one, it's asking, what is the spin results if the product is less than 50? Okay, less than 50, which means my alligator is eating my 50. So everything that's less than 50, well, all of my numbers are less than 50. So it's going to be 16 out of 16, which is 1 whole chance. Okay. All right. Number 8. Number 8 is asking, if the spinner is spun 200 times, how many times do you predict that you would get each product? Okay. All right, so what I'm going to do is I'm going to show this back up here. We are going to use each of these probabilities here to help us answer. So the sum of 2, well, the product of 2, I rolled that 2 out of 16 times. Well, now if I spun it 200 times, how many times am I going to land on it? And I'll go ahead and tell you, I had to look at my notes real fast, that you're going to do 12.5 times all of this. So 2 times 12.5 for every single one of them. So 2 times 12.5, I'm going to use my calculator, which gets me 25 times. So out of 200, I should land on it 25 times. Okay. Let's go ahead and do 6. Well, let's see, I land on 6 4 times. So 4 out of 16 is equal to x over 200. If we leave it as out of 16, we can always multiply by 12.5, which by doing this, I should land on 6 50 times, or the product of 6. Okay. For the product of 3, it's 2 out of 16. So x over 200 times 12.5. Well, we already did that over on the other side, 12.5. So the product of 3, I should land on it 25 times. And then out of 36, not 36, wow, for the product of 36 out of 16 times, that one's going to be a little interesting because you can land on it 12 or 13 times. Okay, you can land on it 12 or 13 total times. Okay. And then the last two, it's saying what's the probability of an even product and the probability of an odd product. Okay, well, my evens, it was 12 out of 16, and my odds is 4 out of 16 over 200, 12.5 over 200, 12.5. Give me just a second, I'll get that to you. So 12, because I did not do that. 12 times 12.5, I should land on them 150 times, and this one I should land on it 50 times. Okay. Should you have any questions, please let me know.